Okay, welcome to lesson 1 of stoichiometry. That's the branch of chemistry that deals with the relative quantities of reactants and products. Whoop. In chemical reactions. Now, we've been balancing equations, so you've seen a lot of equations at this point. We can also interpret the following equation this way. We can use the coefficients as equaling the relative amounts of moles of each substance. So I'm just going to write that down. So we can use the coefficients to represent the moles of substance. As I said, we can use the coefficients to represent the moles of a substance. So remember that the numbers in front of our molecules and elements are called coefficients. So that's what we're going to be using today. So when I'm looking at this chemical reaction, I can also say that this means that I have 2 moles of aluminum. I have 6 moles of HCl, 3 moles of H2, or 2 moles AlCl3. So when I can use those coefficients to represent moles of a substance, that's going to create ratios. Here's some examples of some ratios that can be created using moles. So I could say that I've got 2 moles of aluminum for every 6 moles HCl. Another ratio I could create is 3 moles of hydrogen for every 2 moles of AlCl3. So these are all different ratios. They could also be conversion factors. In fact, we could give them another name, and we could call them conversion ratios. Well, you can see where this is going. If we have conversion factors, we're probably going to be doing factor label problems. And we're going to get to that in just a minute. So remember, initially we did the mole map. We're going to do another version of the mole map right now. So we're going to divide this in half. And we're going to talk about compound A, just to kind of make up some compounds. And we have compound B. In the last unit, we learned that we can convert grams to moles. To do that, we needed a conversion factor where we found what the molar mass was, and that was in the unit of grams, and we had that over 1 mole. And then we could also use a different conversion factor to go to moles to particles, the number of particles in a mole. And we said that the particles could be atoms, molecules, or something we called formula units. These are types of particles. The conversion factor we used to get there was 6.02 times 10 to the 23rd particles in 1 mole. All right, now that's for compound A. Well, in a problem, we may have compound B, and we're given grams. I can get my pen to work here. And of course, I could convert the grams to the number of moles. This time I'll put 1 mole on the top, because remember we can flip these whatever way we need them to. And I can have molar mass on the bottom. You're going to need to grab your calculator, because the unit for molar mass is going to be grams. And I can go from grams to moles, and then from moles to the number of particles. And again, the conversion factor is going to be 1 mole is equal to 6.02 times 10 to the 23rd of those particles. Now the problem is that I've got compound A and I've got compound B, and I need to have a bridge that takes me from one to the other one. So we're going to draw a bridge right here. Here's my bridge. Got some water underneath it. And what this bridge is called, the mole to mole ratio. So in order to go from compound A to compound B, I need to have some kind of bridge that's going to take me from one side to the other side. Let's look at a problem and you'll see how we use this bridge. So we've got 2 AlBr3 plus 2 K2SO4 yields 6 KBr plus 1 Al2SO4 The question is, with 821 grams of K2SO4, how many moles of aluminum bromide would you need? So the first thing I'm going to do is I'm going to identify my knowns and unknowns. Here's a known. Here's an unknown. How many moles of aluminum bromide? The next thing is I'm going to identify where these are in my chemical equation. Well, the K2SO4 is easy because it gives us that. So I'm going to put a box around the coefficient for this formula. Now, aluminum bromide. Well, I'm looking at my formulas. There's only one that has aluminum and bromine in it. So this must be the coefficient I'm going to use for that one. So I'm going to put a box around each of these two. This is going to create my mole ratio. Now, like any other factor label problem, I'm going to start with my known, 821 grams. And this time I'm going to be sure that I write down my formula, because it's important that I know that I'm talking about grams of K2SO4. So I'm ready for my next conversion factor. Well, if I have grams of K2SO4 on the top, I'm going to need grams of K2SO4 on the bottom. And you know that stands for grab your periodic table, because you're going to need to calculate the molar mass. Well, I'm going to give you what the molar mass is. The molar mass of K2SO4 is equal to 174.26 grams per 1 mole. So now I'm going to use that conversion factor in my problem. There's 174.26 grams of K2SO4 in 1 mole of K2SO4. So if I have moles of K2SO4 on the top, you know I'm going to need moles of K2SO4 on the bottom. So I'm going to go to my balanced equation. Here I've got the molar ratio. There are 3 moles of K2SO4 for every 2 moles of AlBr3. So I'm going to put the moles of K2SO4 on the bottom so that my units will cancel out. So 3 moles of K2SO4 are going to go on the bottom. And now I'm going to cross the bridge from one chemical to the other one to 2 moles of AlBr4. Now, my unknown is how many moles of aluminum bromide. So I'm going to go ahead and I'm done. I'm going to make sure my units are canceling off. Grams of K2SO4 is gone. Moles of K2SO4 is gone. The only thing I've got left is moles of aluminum bromide, which is what I needed for my answer. Ready for the calculator. I'm going to pause this, put it in the calculator, and we'll take a look at the answer. All right, put it in the calculator, and I'm going to get 3.14 moles of aluminum bromide. put a box around it so it's pretty. All right, we're going to do one more problem and then we're done. So, same sort of question. Again, I need to identify, I'm going to switch colors just so you can see it a little bit better. So, if you have 21.1 moles of K, how many grams of chlorine do you need? First, I'm going to identify my known and unknown. Here's my known. How many grams of chlorine is going to be my unknown. I'm going to go up here and I'm going to find the potassium, the K, put a box around it. And I'm going to find the chlorine and put a box around that coefficient. So these are the two coefficients I'm going to need. Now I'm ready for my factor label problem. I start off with 21.1 moles of K. K is potassium, by the way. If I have moles of K on the top, I'm going to need moles of K on the bottom. I'm trying to cross a bridge to get to chlorine, which is what I need for my answer, so I can use my mole coefficients. So I need 2 moles of potassium is going to go on the bottom. I'm going to cross the bridge to chlorine. 1 mole of chlorine, Cl2. Now I'm ready for my next conversion factor. I'm trying to get to grams of chlorine. I have 1 more mole of chlorine on the top, so I'm going to need to have 1 mole of chlorine on the bottom, Cl2. And I'm trying to get to grams, so that means I need to grab my periodic table. So chlorine is Cl2, so I need 2 of them. Each one is 35.45. So when I put that in the calculator, I'm going to have a molar mass of 70.90 grams per 1 mole. So 70.90 is going to go on the top. Let's double check and make sure that our units are all canceled off. Moles of K, moles of K, moles of C, moles of C. I'm left with grams of Cl2. And now I'm ready for my calculator. I'm going to pause the video as I put this in. I'm going to need 3 significant figures because of this number here, 21.1. And so I round my answer to 748 grams of Cl2. So that's how many grams of chlorine I'm going to need if I'm doing this reaction. That's where we stopped in class, and that's where I'm going to stop tonight.